In this video, we're going to discuss how p-values can be used to perform hypothesis tests on intercept or slope parameters. An alternative to using t-tests is to use a p-value. And a p-value is the exact significance level for a test of the null hypothesis that beta j equals 0. You specify the significance level just as you do before, and then you compare the p-value to your significance level. So if you're using a significance level of 5%, if you get a t-ratio, which gives you a p-value of less than 5%, that means that you're in the region which would have been the rejection region using the other more traditional type of approach, and you'd be able to reject the null hypothesis. In other words, if the p-value equals 0.024, that tells you, given that t-ratio that you've estimated, there's an estimated 2.4% probability of committing a type 1 error. If you were willing to accept up to a 5% chance of an error, then you would reject that null hypothesis. On the other hand, if you're using a 1% significance level, you would not if your p-value is 0.024. And pretty much all modern econometrics and statistical packages will estimate not only t-statistics, they'll also estimate p-values. The p-value for a one-tailed test is always going to be 1/2 of the reported p-value for a two-tailed test, because the p-values that are reported by the regression package are based on the assumption that it's a two-tailed test, which if you get a t-statistic of 2.3, the p-value would be the probability of being above 2.3 or being below a negative 2.3. If instead you're using a one-tailed test, you're only concerned about the rejection region on one side of that, so the p-value would actually be 1/2 of that.